So this video is going to be a little bit different. I've been experimenting a lot with coding agent harnesses, and I'm building one from scratch right now, and I thought I might as well make a video about the very core of every coding or AI agent and try to simplify it as much as possible, and really reduce it to the core agent loop. So yeah, I'm gonna go ahead and implement this in about 50 lines of Python code. What we're going to use is OpenAI models, and so we are also going to use the OpenAI API and their Python package for simplicity. And the first thing we have to realize is that a AI model or large language model is not the same as an agent. We take a model and we build the agent around it to give the model the ability to interact with its environment. But what is happening is actually not so different to the usual conversational AI that we know from ChatGPT since it came out. So the way this is built up is in a message chain. So a list of messages from different partners in this conversation. So one would be the user, so the user who wants something from the AI model, and one other side would be the model responding in some kind of way. And then for agents, we have this this other role, which is the tool, and I will come to that. But for now, let's build a very simple message chain, and the way I'm building it up here is just in the convention of the OpenAI API. It varies from provider to provider, but this is kind of how every message chain is built up. So we have some role, which is user in this case, and some content, which we can say is some prompt like what is the capital of Austria. And so this is our message chain, and then we want to send this to a model. This would be the very basic use case of a model. So we want to get some kind of response by making an API call to the OpenAI model, and we have to actually implement this function, which takes in the message chain and then returns, and we're going to use here the chat completions endpoint. It's an old endpoint, but it allows us to really see this message chain being built. And we have to define a model. Let's take the latest one, GPT 5.5, and we have to pass in our messages. And then we can also define some tools, which we will do later. For now, let's keep it simple, and let's also here do this just to select the right part of the response, and then here we are gonna just print out the message content to see what the model will answer to our question. And we see it's answering our question just in a very basic way. Now we could now go ahead and take this message that we got from the response and actually add it to the message chain, and then add another one, which could be like another user message following up on that and asking, because we know that it's going to say Vienna, we can say, are you sure about that? And now with this we could again make another API call, and let's print that and see what then is and let's actually print both, and let's see what comes out of that. And that's the usual way to use a conversational chatbot is, okay, you get some response, you write a message back, and then you get another response, and you build up a message chain because you always, the model itself doesn't remember anything. You always have to pass the whole conversation from the start. So this is kind of the conversational way of using AI models. But now we will add tools to the conversation, and the way we do this is we define a tool for the model, or several tools, but we will just work with one. We define a tool for the model, and the model can't actually use the tool, but we can give it a definition of what text it should generate that we can use to use the tool. So basically, the best tool to use with text that can do a whole bunch of things is the shell, and the shell is what I have down here. So this I can run text commands in here, and for example, make a folder, and this will pop up here, and this is the command to make this folder. Or I can list the files in this folder and execute software, use other tools, all kinds of stuff. And this is really the most important tool for any AI agent or coding agent at the moment, because it allows it to run so many commands for doing all these things, and it only works with text, and that's the thing that tools need for us to be able to have a model generate text that we can then use to use this tool. So the way we define a tool, and this is again some convention of this API. This is not really so important, but we define a function, it's called here, and give it a name. Let's call it shell in this case, and then we have to give it some parameters, and these parameters have a type, which would be here object, and some properties, and I should put a comma here, and add properties, and these properties are now what the model actually gives us, and we tell it this is of type string, so just a text field. So what we did here in the definition is we tell the model, okay, there is this tool shell, and the way to use this with text is by using a command, and this is just a string. So just like I did this here, so this would be a command to run in the shell. We tell the model this is what we can do, and you can give us a text that we then run in the shell, and give you the result back. So this is the tool definition, and then it's up to us to actually execute what the model wants us to do. And so we make another function to execute shell commands, and we take in a list of tool calls, because the model can decide to give us one or many commands that we then have the responsibility to execute. And as I mentioned before, the results of the tool calls will become just more messages in this message chain, and they will look like this with the role tool. So they will just be added to the message chain as tool results, and then passed back to the model so that it sees what its commands actually led to. So we will build up this tool messages list and just iterate through the tool calls, and for each one we can we have to execute the command. So we will use a package called subprocess, and we also need JSON. So this allows us just to execute this command, and the way we do this is with subprocess run. We pass in, and we have to use JSON just to extract the actual command. So this would be tool call function arguments. So this is where the arguments of the model will be for this command, and here we have to extract the actual command like so. And then we have to pass in here some other arguments just to give us the right output. So this will look something like this, and we wanted to actually execute shell and give us text. And then we have to extract the actual output. And yes, and where does this go? We I already mentioned we build up a message from this with role tool. Then we have to also add a tool call ID, it's called, which is just a way for the model to identify which command belongs to which result. So we get this from the model. We just have to give it back to the model so it knows what belongs to what, and then the content is going to be the result of this executed command. And then when we have done this for all commands, we just return all the messages in this function. And yes, and we can actually see how this works when we now work with a different prompt, because we have to now make the model actually want to use a tool. So let's do something like list the files in this folder, and now we print just the whole response and see what the model gives us back. Now we gave it the whole tool definition and this prompt, which it can't just answer like this. It has to, or it will know it has to use a tool for this, and luckily it gets this tool definition for the shell, and the model is trained to use the shell a bunch, so it will know, okay, this allows me to get the information I need. And what we see here, this is a bit messy, but in here we see it's actually doing giving us a command. So here's the command it wants us to run, which is ls -la, so a command to list the files in a directory. And we have the tool call ID here, and everything we need. And by the way, this is, we can see what when the model response of role assistant. So we will also always take this message that the model generates and also add it to the message chain, just so the next time we call the model, it just knows what it did last time, because it can't remember without us putting this into the message chain. Okay, so now we ran the model with this tool definition, but we just got one response. Now we want to add this to the message chain and run the model again and see what it does then, and it will decide to run the tool another time or write a final message. So this is kind of the loop in any agent. There's some user input, the model uses some tools, writes a final message, and that's it until the user wants writes a follow-up question or another task or something to do. And so now we actually have everything to build this full agent loop, and it will start just like we have started all along, but we will continue with going into a loop that just checks for this finish reason, it's called, and we want this to be tool calls, because when it's tool calls, it means the response from the model has a command that it wants us to run, and we have to actually execute it and give it back to the model. So we do this by using our function that we have. We give it the tool calls, we execute them, get them back into this tool messages list, and then we add the assistant's response or the model's response, so the response message, as well as all the tool messages into the message chain, and yeah, we make another API call with the extended message chain, and we do this until the model doesn't want us to run the commands anymore, and then we know, okay, it just wrote a final response now. Just so we can see what's happening, I will add some print statements here. So let's actually do this like this for each tool call in the tool calls. We will print out, and let's format it in a nice way so we can actually see what is happening. And let's add the tool call and its function arguments, and then add another one like this, just so it's formatted somehow nicely. And let's also do that with the tool results. So for tool message and tool messages, let's also print tool result, and this will then be tool message. I think it should be content, yes. Yes, and then in the end, let's when we go out of the loop, we know, okay, this is the final response now in the last model call we did. So this will then be content, and yes, this is our whole agent loop. So let's test this now actually and see what is happening. So we can see now that we ran or we started off with our user prompt to list the files in the folder, and we passed this to the model. The model gave us a command to run, which is ls-la, a command to list files. We actually ran this command then, which had this output, a list of all the files, and we gave this back to the model, and the model had all the information it needed, and just gave us a final response that is well formatted in some way. We can even take this a step further and give it a little more complex task. So let's say make a folder and in it make a Python script and run it, and I would tell it to use separate commands, just because I know GPT 5.5 is keen on using one big command for everything, but I want to show how it's iteratively using commands or being able to do so. So we can see the first thing it did was give us a command that makes a folder, and we executed this. The empty tool result is in this case actually a success, so the model knows, okay, this was successful. It gave us a command to make a file and write something into it. This is what we executed then, and it gave us a command to run the script, and it got this result back, and then gave us the final response that it's done. So yes, this is the full agent loop. We are at not even 50 lines of Python code. I think this is really cool to see that it's really that simple to build a agent loop with a off-the-shelf model. And obviously the systems we know, like Codex or Cloud Code or Copilot, they have much more components then, because they need permissions, security, authentication, all this stuff. So they are very big systems. But I think it's just worth knowing that at the core, every agent loop, every coding agent, AI agent, is essentially this. So you can find this code on GitHub. I will add the link, and hack around with it. And thank you for watching.